So good morning to one and all. The previous class we have finished the EMMC instrument. So we have already discussed about the torque equation and working construction, working principle, and some numericals also we have discussed. So the next instrument we are going to discuss, that is called moving iron type instrument. Okay. So just I will do the regular checkup that screen is visible.
Yes, sir.
Okay.
Yes, sir.
So in that I got two answers. Screen is visible, it indicates that it is audible also. The question itself answer is there. Okay. So the operation for the moving iron instrument and the PMMC, it is little different is there. Little different is there. So this type of moving iron instruments we are going to use in the switchboards we are going to use. Yeah, I think you have visited any substations and all the things. In that one, they are going to use some small mounted on the wall or some boards are there. There they are going to use that voltmeters, emitters, and all the things here, voltage and current. So moving iron instruments are used in the laboratories and switchboards at commercial frequencies. Commercial frequency is nothing but it is not a residential, whatever the standard frequency 50 hertz is there. It may be different. It may be 500 hertz. It may be 200 hertz. Okay. Based on their requirement, whatever the manufacturing companies are there, based on that requirement, the commercial frequencies will vary. According to that, we are going to fix this moving iron type instruments in the switchboards or in that laboratories. We are going to use this one. This is the application of moving iron instrument. So the main use and advantage is it is cheaper. The rate of this one is very cheap and more accurate here. Whatever in the instrument, our laboratory we are going to use, that is called PMMC or EMMC we are going to use. But here, this iron instrument, moving iron instrument rate is cheaper than that PMMC. We can compare that one and it will give the accurate answer. Why it is cheaper, I will tell you now. Later I will tell that one. Once the principle if you understood, then easily you can tell the answer for that one here. So these moving iron instruments are again classified into two types here. The moving iron instruments are classified into two types. So the all of you know the characteristics of the magnet is attraction and repulsion. Yes, the main function of the magnet. What is the function of magnet? The opposite poles attract each other and same poles, like poles, repulse each other. You know already very well about this magnets and all the things. Okay, these based on the function of the magnet, we have classified the moving iron instrument into two types. The first function of the magnet is attraction. So attraction type we have used. Second type, that is called repulsion, we are going to use. So repulsion type we are going to use here now. Repulsion type. So attraction type and repulsion type, there are two types of moving iron instruments are there here. So again, this repulsion type is again classified into two types. Again classified into two types. This repulsion type is again classified into two types here now. Those two types I am going to explain in the radial and coaxial repulsion type moving iron instrument. Radial and another one is coaxial. Once we'll start the explanation of this one, then we'll go for that. Okay, the function is same based on the structure of that whatever the iron we are using. Based on that, again we have classified the repulsion type into two types. So mainly moving iron is classified into two types, that is attraction type and repulsion type here now. So we'll start the attraction type now. We will discuss the principle of attraction type. We are going to discuss. Number 27. Okay. बोलो सर. So attraction type, the iron instrument, attraction type, moving iron instrument. The main principle of this one is here one, the name itself it is indicating here no moving iron here no. The iron part whatever we are using in this instrument is that is moving type here no. So we are using a permanent magnetic field, the fixed magnetic field we are using here now. Two magnets are there here, the coils we are using here now. So whenever the current will flow through this coil, it will act as a magnet. This iron core will act as a magnet. This one, in between these two coils, the magnetic field will be produced, and we have kept one moving iron here now, flat iron piece we have kept here now. In between the magnetic field we have kept the iron piece, means it is going to attract the iron and magnet. If we brought near to that one, it will attract or not? Yes. If I have the iron piece and I have the one iron magnet, whenever I will bring the magnet into the iron piece, the iron will get attracted to the magnet. Yes or no?
Yes, sir.
So that principle only we are using here now. So magnet and iron we have used here now. So the soft iron piece brought near a magnet, it will get attracted to the magnet here now. One small piece of iron piece, if we brought near to the magnet, then it is going to attract over there. So attraction is nothing but it is going to move from that position to the towards the magnet here now. Same principle we are going to apply here now. So that principle we are going to apply for the attraction type moving iron instrument. Based on that principle only, the moving attraction type moving iron instrument is going to operate here. So this is the principle. Next, the construction we are going to consider here now. See this diagram. Look at this diagram here now. See here two coils we are using, coil C and C here now. These are the fixed coils we are going to use here now. Those are fixed coils here now. This will act as a magnet here now. And one flat moving iron disc we have used here. This is moving iron disc, that is called D we have used here now. So for the controlling purpose, we are going to use some weights we have added here now. For the damping, we have used air damping here now. And this flat moving iron disc, it is connected to the spindle here now. So that spindle is connected to the pointer here now. Whenever the spindle will moving iron will rotate, then the spindle will also rotate here now, which is connected to the air piston rod and pointer. So once the pointer will start to move, the air friction rod will come towards here now. Outside it will come, and whenever it will come to original position, again it will going to push over there here now. So the fixed coil C we have used. Two fixed coils are there. One moving iron instrument flat disc is there here now. The coil is flat and has narrow slot like openings here now. These are the narrow slots like a opening here now. Two coils we are using here now. Coil is, it is a flat we are going to use here now. The moving iron disc is also flat here now, which is eccentrically mounted on a spindle here now. So this is also one flat disc we have taken here now, and which is mounted on the spindle. Spindle ke on the upper we have mounted that one here. The spindle is supported on a jewel bearings. Why the bearings are required? Which will helps to rotate easily. Easily we can rotate that one. So the bearings we are going to use here now. So the spindle carries pointer which moves over a graduated scale here now. So I will tell you one by drawing diagram here now. So you consider this is spindle. This is spindle. That is spindle.
म्यूट झालाय सर.
Just a minute, just wait a minute.